Welcome everyone. Myself Dr. S. Naveen Prakash, working as an assistant professor in Department of Electrical and Electronics Engineering in Welltech Multitech, Dr. Rangarajan, Dr. Sakuntala Engineering College. Today we are going to discuss about a very important topic in electrical engineering, that is electrical drives. Generally, electrical drives from the core of all motion control systems used in industries, robotics, and even electrical vehicles. Let us explore how they work and their components and the components of electric drives and also variable speed drives. Welcome to all. Before going to the session, we just know about the definition of electrical drives. Generally, electrical drives consist of various systems combined together for the purpose of motion control or movement control, especially the drives which employ electric motors for motion control are known as electrical drives. Otherwise, an electrical drive is a system that controls the motion of an electrical machine. It converts electrical energy into a controlled mechanical energy to a drive mechanical load. In other words, an electrical drive helps us control the speed, torque and direction of an electric motor as per the requirements of load. Generally, the electrical drive system consists of few blocks. The basic and important blocks of the drive system are power source, power modulator or converter, electric motor act as an electrical drive, and the control unit, and as a final is a mechanical load. And here is the electrical drives, and 50% of electrical energy is used for drives, can be either used for fixed or variable speed, and 75% of application using constant speed and 25% of using the variable speed applications. And here is the example for variable speed drive applications, and figure shows the VSD application here. And next we are going to discuss about the applications of electrical drives. Here figure shows the application for electrical drive act as a single motor versus single load. That means single motor drives a single load application like a washing machine and electrical disk drives and electrical cars. Generally the electric motor drives a single load or single application. Generally, it's electric saws and drills, fans, washer machines, blenders, and disk drives. There is a floppy and a electrical cars. Here is a single motor drive the single load system. And here is the application of multi-motor drives. Here, using several motors drives a single mechanical load. That means the group of motor drive a single load. This function generally is a complex drive function. Examples: assembly lines and robotics, military, aeroplane actuation. And general application of electrical drives are paper mills, electric traction, cement mills, steel mill, etc. Here is the definition of electrical drives, and here shows the various definition of electrical drives. And next we are going to discuss about the conventional variable speed drive system. Generally, conventional variable speed electrical system used in many industrial and traction applications. It is necessary to control the speed of electric motors smoothly over a wide range. Before the development of power electronics and mechanical and electromechanical methods were used for variable speed control. One of the most important classical systems is used in speed control, that is Watt Leonard control system, which uses both AC and DC machine to achieve the variable DC supply for speed control of a DC motor. And the basic principle of this conventional system is convert AC power is converted into mechanical power, and that mechanical power is converted into DC power, then that DC power is converted again into the mechanical power. The system consists of AC motor and DC generator and a DC motor. The DC generator's output voltage is varied by adjusting the field excitation of a DC motor, which in turn control the speed of a DC motor driving the load. And the construction of the system, uh, before going to explain the construction, we are discussing about the components of the drive system. First of all is the AC motor and the DC generator, the DC motor and load system. First of all, the AC motor operates at a constant speed using AC supply. Here is the AC motor. Here is the AC motor using the AC supply and operating a constant speed. It provides a mechanical drive to the generator. Act as a prime mover here. Typically, and as a induction motor or a synchronous motor act as a input drive for the generator. Here it is run at a fixed speed, that means a constant speed from the input supply. Then second one is a DC generator mechanically coupled to the AC motor shaft. Here shows the diagram and converts the mechanical energy from the AC motor into the variable DC voltage through this DC generator segment. Output voltage controlled by the adjusting by the field current of the generator. And third segment is a DC motor. Receive the variable DC voltage, that means the armature voltage receives from the generator. It drives the mechanical load, and here figure shows the DC motor is coupled with the load is a variable speed. So the DC voltage drive the motor, and motor coupled with the mechanical load. It drives the variable speed, and torque and speed of the system depend on the armature current of the DC motor and applied voltage. And here is act as a load. Any mechanical system requiring smooth speed control, example elevators, cranes, and rolling mills. And the working principle of the system, the AC motor runs at a constant speed and rotates the DC motor. By varying the field current, that means the IF of the generator, the output voltage can be increased or decreased. Then the variable DC voltage fed into the armature system of the DC motor. The speed of the DC motor is proportional to the applied voltage, and speed n equal to V minus IARA divided by 5. And here is the n is the speed of the DC motor, and V is the armature voltage of the machine, and IA is the armature current, and RA is the armature resistance, and phi is the flux per pole. Thus, by controlling the V, I mean voltage through the generator field current, and motor speed can be varied smoothly. And the speed control features smooth and continuous speed operation. It is a 4-quadrant operation also possible. And the first one is a forward motoring and forward braking, and reverse motoring and reverse braking. And speed reversal achieved by reversing the polarity of the generator output or motor field. And the advantages of this system, Baudrillard system, is very smooth and stepless speed control, excellent dynamic response, and torque control of the system. Wide range of speed control from 0 to above the rated speed, and the high starting torque and easy reversal of the rotation. And the major disadvantages of this very conventional variable speed electrical drive system: bulky and expensive. And here is a disadvantage: the bulky and expensive, and inefficient compared to some ways, and complex function, and low efficiency due to the multiple energy conversion. That means the AC mechanical is converted into DC, and the DC is converted again into the mechanical. So it is required some high maintenance like brushes, commutators, and couplings, and the noisy operation. And another is a noisy operation. Requires a large floor space for occupy and install the machines, AC motor, generator, and again one DC motor and drive applications. And finally, the applications of the system is elevator, hoist, and cranes, rolling mills, required variable speed for processing material, mines, winders, traction system, etc. And modern replacement, the Watt-Leonard system has been largely replaced by static drive system. That means the thyristor-based DC controlled drives, variable frequency drives for AC motors. These modern systems offer higher efficiency, compactness, and less maintenance. Next, we are going to see the right. Next, we are discussing about the modern electric drive system employing power electronic converters. Okay. In the starting point, this is the input supply, and this is the input supply to our device. It can be connected either AC, like from the utility mains, or DC, such as from battery or solar system. The main purpose of the power source is to provide the raw electrical energy that will be later controlled with the supply to the motor. Next, we move to the power processor. We move to the power processor, also known as the power electronic converter. This is the heart of the entire drive system. It uses semiconductor devices such as diodes, thyristor, IGBT, and MOSFET to convert electrical power from one form to another form. Depending on the requirement, it can be performed the conversions like AC to DC using as a rectifier, and DC to AC using as an inverter, and DC to DC using a chopper, or AC to AC using a cycloconverter. The main objective of this unit is to supply main objective of this unit is to supply to the motor with the required voltage, current, and frequency for their efficient operation. Now the motor receives the processed electrical energy, the converter from the converter, and converts again it into mechanical energy. The motor drives the load, which coupled, I mean, which could be a pump, fan, conveyor, or any mechanical system that needs motion. The performance of the load directly affects the torque and speed required from the motor. And next one is the control unit, and this is the brain of the system. It generates control signal that regulate the power processor, ensuring the motor operates according to the desired speed, torque, and position. The control unit can be implemented using microcontrollers, digital signal processing units, or modern digital controllers. We can also see a feedback path coming from the motor back to the control unit. The feedback signal may carry the information about the motor speed and current or position. It is based on the feedback. The control unit continuously compares the actual performance with the desired values and make the necessary adjustments. This process makes the system a closed loop drive, ensuring a smooth, accurate, and a stable operation. Finally, summarize the modern versus conventional. The power source provides the energy, and power processor converts the and conditions that energy. The motor converts electrical energy into mechanical motion to drive the load. To the control unit, with the help of feedback, ensure the everything runs efficiently and precisely. So, this is how a modern electric drive system works, combining power electronics and control technology to achieve an smooth and efficient motor control used in industries, automation, and electric vehicles. And as the multidisciplinary nature of electrical drive system is a non-linear control, real-time control, and digital signal processing applications, and etc. And here is the basic components of electrical drive system as discussed in previous slides. And basic components of electrical drive system: there is a power source, it's a regulated power supply, either it is regulated or non-unregulated, and DC source, batteries, fuel cell, photovoltaic, and AC source, single or three-phase utility, wind generator. And the basic components to provide the regulated power supply to the motor: the combination of power electronic converters, that means the control rectifier inverters, treated as in black boxes with certain transfer function. It is more efficient, flexible, compact. Here is the basic components. Okay, thank you for listening.